Come back to my YouTube channel. Today we are going to solve a medium question on lead code, lowest common ancestor of deepest leaves. Let me read the problem statement. Given root of a binary tree and return the lowest common ancestor of its deepest leaves. Uh, so Here they are given some points. The node of a binary tree is a leaf if and only if it doesn't have any children. So let's take one leaf child. Let's say this one. It doesn't have any child. So because of that, it is a leaf child. If you take node of one, it has two children. So it is not a leaf node. Uh, so we'll have to, let's say there were uh, some n deepest leaf nodes. From there, what is a common ancestor we'll have to do. If you don't know the what is a common ancestor, if you take a node 2 and 0, the common ancestor can be 3. And if you take 7 and 4, the common ancestor will be 2, 5, 3. And the lowest one is the 2 for these nodes 7 and 4. So, whichever the lowest one, which is common to the nodes, that will be the ancestor of it. So that is lowest common ancestor. So we'll have to find, uh, let's say there were no nodes 7 and 4, and the deepest leaves are 6 to 0, 8. In that case, 3 is the answer. But in this test case, the deepest nodes are 7 and 4. These are the leaf nodes 0, 8, 6, but those are not the deepest because 7 and 4 are one level down compared to this one. So this 3 is uh, level 0, depth 1, depth 0, and this is depth 1, depth 2, and depth 3. So what we can do is maybe we'll find the what is the maximum depth of a given tree and see whenever we encountered a maximum depth, we'll try to return its node to its parent. And if both nodes are common, let's say they were nodes, then this root is the common ancestor. If one of the nodes is null, let's say, we will be returning the other node. Let's say in case of 7, 2, 7 will be written here, and this 2 will be written back like that. So that is all about it. Like we seen a question like find the lowest common ancestor of two nodes in a given tree, but here the instead of two nodes, there will be n nodes. What are those n nodes? Are deepest leaves. Uh, that is the problem statement here. It's just a modification of finding lowest common ancestor of two. It's just an extension of it. If you know how to solve that question, it is very easy to solve this question. First, we will try to find the depth of a tree. Let's say depth will be. First, we will find the maximum depth for a given node. So let's. Um, we will define a method here. And here we will pass in the root. And if root is equals to null, there is no depth, right? So -1 else. if there is some root, so we will be going one level deep. So 1 plus. What is the depth of from the left and right children of that node? So left, mm, we will have to take the maximum because we are finding the maximum depth, right? In the both trees, left and right children, we will have to find the maximum depth. Okay, this will be the depth of a given maximum depth of a given piece. Let's find the deepest leaves now. Uh, let's say this method will return the lowest common ancestor of the deepest leaves. Let's just call lowest common ancestor depth max depth. Okay, and we will pass in the root, the max depth as well. Okay, and let's name this as see. So it will return a tree node, which is nothing but LCF at max depth. We will pass in the tree node root and let it as we can call it as any depth, right? From of max. Now, if current root is equals to null, uh, there won't be any lowest common existence, so we will return null. Let's say the depth, let's say we have reached the lowest depth. Let's say we keep decrementing it, then we'll have to return the node. Otherwise, what we will do is let's store in will what node it has written. So where left is equal to LC at max depth. We will decrement the depth. So when it reaches 0, we will return that node. Let's say in this case, the maximum depth is 3. Currently, we have 3 here, then 2, 1, 0. So we return 7 back here. And similarly, we return 4 because the depth is 0 here in this level. And since these two nodes are not null, we will return the current node, which is 2, and we return 2 here. And this right subtree will return null eventually because it will go to the leaf and it will return null and it will propagate up. And finally, this 2 will propagate up. So this subtree will be written back. So let's say find the low minus 100. Now, if both equals to, let's say both are not null, this is the case, then we will return the root. Or else, if left is equals to null, we will return right, else left, anything. This is it. Let me try to uh, run the sample test case. It is passing the basic test cases. Let me try to submit this problem. It failed. Let me check once again. If it is okay, so okay, we have to pass in root dot left and root dot right. Yeah, this is the issue. Okay, pass. And let's do time and space analysis. Time and space. Let's talk about the time complexity. This depth function will visit all the nodes. So let's say there were n nodes, it will take n time to visit. So the depth will take big O of n plus this LCA of depth is also traversing all the nodes left, right? So another big O of n. We can say big O of n overall. And coming to the space complexity in the depth function, we are doing a recursive call to the same function. So let's say the given tree is Q tree. In that case, in all the nodes, like that many nodes will be stored in the stack. So it will be like big O of n. And for the LCA also the same case. It will be big O of n here as well. So overall, big O of n time complexity. So if you know how to solve the lowest common ancestor of a given tree, lowest common ancestor of two nodes in a given tree, then you would easily solve this. Like it just that instead of this case here, the lowest common ancestor is based from starting from the deepest leaf. Instead, we will find the two nodes like node 1 and node 2. Whenever we find these nodes, we will return the root here instead of depth. That is the only difference. Remaining code is same. It just we will be calculating the depth in the first case. So that is it. Maybe in the similar questions you will see this lowest common ancestor of a binary tree, maybe. So if you like this video, please like, share, and subscribe to my channel. And see you next time. Bye.